In this video we're going to look at trigonometric functions. Just three things to note. One, angles are measured from the positive x-axis. So for instance, if I measure an angle, I will measure it from this point. Positive angles are measured in anti-clockwise direction. So anti-clockwise direction will be that direction. And negative angles are measured in clockwise direction. So a negative angle will be measured from that star this direction. So for instance, let's look at our 60 degrees. It's a positive 60 degrees. We start our measurement here. Positive 60 degrees, we go 60 degrees this way. So that's it. So there. 110 degrees, again it's positive. We measure from here. And it'll get us to about here. Next one, minus 60 degrees. This is negative. We're starting the same place, the positive x-axis, but this time we're measuring clockwise, 60 degrees. So here. And lastly, minus 2 degrees. So again, it's negative, so we're measuring clockwise, and it's 200 degrees. This way. So here. Okay. Next thing we're going to look at is the unit circle. I could just say this is a unit circle and learn off the CAST, and I would say that what that stands for is the C stands for cos, all, sine, and tan. And what that means is if there's an angle in this, whether it's sine, cos or tan, it's always positive. However, in this quadrant here, the only ratio that's positive is sine. In this here, the only ratio that's positive is tan, and here the only ratio that's positive is cos. And I could say learn off by heart. However, we're not going to do that. We're going to see why. Right, let's look at this here, the tan 45. If you look in your logbooks, tan of 45 degrees equals 1. Okay, so what that means is, have a look here, tan equals the opposite over the adjacent. So that means the opposite side is the same as the adjacent. Why? Because it gives a value of 1. Right, so if the opposite was 5 and the adjacent was 5 again, we get an answer of 1. Okay, so let's look at this 45 degree angle. We're going to put it here. Okay, we draw a line down, draw a line across. We can see that the distance from here to here is the same as each other. And if we put those distances over each other, they will of course be the same as each other, so we get an answer of 1. So that's why the tan of 45 is 1. Now just bear this in mind. Let's say, I know it's the unit circle, but let's imagine it as the x and y axis. So this being the center, this is the positive x-axis, this is the negative x-axis, positive y, negative y. Okay, so if we look here, that's positive, isn't it? Okay, so from here to here is positive, and this is also going to be a positive answer. Right, so when we're looking at tan, we have a positive over a positive answer, which will give us positive. So any tan angle in this quadrant, so basically from 0 degrees to 90 degrees, will always give us a positive answer. Now let's look at this. We'll take, let's say, minus 45 degrees, which is in fact 350 degrees. Minus 45 degrees is down here. So where it hits there, goes across and goes across. Right. So this is positive. However, this is going down. This is the negative y-axis, so that will be negative. Okay, so when we're looking at this angle, this 45 degree angle, well, I can say that the opposite is a negative and the adjacent is positive. So the opposite is negative, the adjacent is positive. So minus over a positive, which will give me a minus answer. So in this quadrant here, tan will be negative. So I'm after showing that in this quadrant tan is positive, in this quadrant tan is negative. Let's look at 135 degrees, which would be here. Again, it's a 45-degree angle from this axis. Okay. Now, if we look, our opposite side it's going up the way, so it's positive. However, the adjacent side is negative. So the opposite is minus, the adjacent is plus. Sorry, it's the other way around. Plus over minus. Plus over minus will also be a minus. So in this quadrant, tan will be negative again. And that makes sense because look, there's an S here. So the only, I suppose, ratios that will be positive here are sine. If we look at this, draw a 45-degree angle down here, that's 220 degrees. So that's that. Draw a triangle. Notice this opposite side is negative because it's going down the way. This adjacent side is also negative because it's going on the x-axis, is going negative. A negative over negative is a positive. So we get a positive answer. And look here, tan is positive in this quadrant. Right, so we've dealt with our tan. I'm going to deal with cos, and you can pause the video and you can deal with sine if you want. Right. Note that in this, the opposite and the adjacent can be negative or positive depending on what quadrant it is in. However, the hypotenuse will always be positive. Okay, so hypotenuse always positive. Right, let's look for cos of 60 degrees. Well, we start here, we'll be measuring from here, 60 degrees will get us to here. Okay, so notice the hypotenuse, which is here, well, that's always positive. Positive. And notice then the opposite side, which is here, that's positive because it's going on the positive y-axis. So cos is adjacent over hypotenuse, and the adjacent is plus and the hypotenuse is plus, and therefore we get the plus answer. And that would make sense because all sine, cos or tan is positive here. If we look at 120, it's going to be here. Draw a triangle here. We look for this angle. We'll say that is positive, okay, because the hypotenuse is always positive. This is also, so the adjacent is negative. So we have a minus adjacent over a positive hypotenuse, which will give us a negative answer. And look that. And so in this quadrant, cos is negative, and that makes sense because the only ratio in this quadrant that is positive is sine. Okay, so I hope that kind of helps you out a bit as to why we have this CAST and why certain ratios are positive or negative depending on what quadrant they're in. Okay, so remember we said already we always measure from the positive x-axis. We always start our measurement here. Plus this way, minus this way. Also, this is a very important line here, this x-axis, okay, because from this axis we'll be getting a thing called a reference angle. Okay, what a reference angle is an angle really between 0 and 90 degrees, positive or negative. Okay, that's very important for us. What you're going to need to use here is our log tables on page 13. Right, and the best thing I can do here is just do a question and show you how it works. Okay, so make sure you have your log tables out on page 13. Right, so first question, find in surd form sine 120 degrees. Okay, well, sine 120 degrees. Okay, first thing is it's positive, so we're going to be measuring this direction. So 120 degrees will be about here. Okay, but that 120 degrees is more than 90, so we need a reference angle. The reference angle is this here. Okay, it's the angle between, I suppose, the 120 and this x-axis, this yellow line. So we know that that's 60 degrees. Okay, because from here all the way around to here is 180, so 180 minus 120, 60 degrees. Okay, so instead of looking now for 120 degrees, we're looking for the sine of our reference angle, which is 60 degrees. And if we look in our log books, the sine of 60 degrees is a half. Okay, so this point here in surd form is a half. Now we ask ourselves, is it plus a half or minus a half? In this quadrant, sine is positive, therefore it's plus a half, or a half. So sine of 120 degrees equals positive a half. Next one, cos of 225 degrees. So cos 225 degrees. It's positive, so we'll be measuring anti-clockwise. Get to 180 is here, and then down here. So from here to here is 225 degrees. But this is more than 90 degrees, so we need a reference angle. So I'm looking at this yellow line going across, and I'm taking that as my reference angle. 45 degrees. So reference angle is 45 degrees. Check out what the cos of 45 degrees is in your logbooks, and you get 1 over root 2. Now you ask yourself, is it a positive 1 over root 2 or a negative 1 over root 2? Well, in this quadrant, tan is positive, all the rest are negative. So therefore, cos is negative, so it's a minus 1 over root 2. So this is minus 1 over root 2. So that's that done. And the next one, cos minus 135 degrees. Okay. So it's cos minus 135 degrees. It's minus, so we'll be going this way. 135 degrees. We'll be back this way. And there we go. But remember, this again is more than 90 degrees, so we need a reference angle. Again, the reference angle is going to be here. 180 minus 135 is again 45 degrees. So we need the cos of 45 degrees. And the cos of 45 degrees is 1 over root 2 again. And we ask ourselves, is it a positive or a negative answer? Well, in this quadrant, again, tan is the only one that's positive. So this will be a minus 1 over root 2. And here, minus 1 over root 2 again. Okay. Lastly then, we have these two questions, which are kind of just the opposite of these. Right. So the first one, if sine x is minus square root of 3 over 2, find two values. Yeah, generally we're going to get two values for these. For x, if x is between 0 degrees and 360 degrees. Okay, first step here. We find out what the sine of, and ignore the sign so far, right? We find out what, how many degrees root 3 over 2 is, the sine of root 3 over 2 is. So again, look at our logbooks, and sine of root 3 over 2 is 60 degrees. So I'll do it up here. Sine minus root 3 over 2. Well, sine of root 3 over 2 equals 60 degrees. Okay, so we have 60 degrees here. But now notice it's a minus answer. It's a minus sign, root over 3. Okay, so we're looking for quadrants that sign is negative. So sign is negative here and here. So here's what we do. We use a reference angle. We use this as a reference angle, 60. So we measure 60 this way from the reference angle. We'll get to, suppose, here. And also then, from this section, another 60. And we get to here. Now, why didn't I measure into these quadrants there, A and the S? Because if I put the 60 degrees up there, well then these quadrants would give me plus answers. And look, I have to have minus answers. Right. So, let's see what my answers are then. Remember, this was my reference angle. Okay, I used the root 3 over 2 to get my reference angle of 60. Then I looked here to see if it was positive or negative. It was negative. And then I used my reference angles to draw my angles in these quadrants. Okay. So from here to here is minus 60 degrees if I was to measure this way. Or, and this is the way I'd like to measure, it's from here all the way around to here, which is 360 minus 60, which is 300 degrees. Okay. So one of my answers is 300 degrees. The other one then, and again, I like measuring positively, so I'll go from here all the way around to here, which would be 180 plus 60, which is 240. So 240 degrees and 300 degrees. Maybe I suppose I should really say R. So, if we look at what we're asked, if sine x equals minus root 3 over 2, find two values for x if x is between 0 and 360 degrees. Well, the two values are 240 degrees and 300 degrees. Okay. Right, last question. We'll just tidy up here and we'll go again. Okay. Right. So, if sine x is a half, find two values for x if x is between 0 degrees and 360. Sine x is a half. Right. Sine x equals half. Okay, let's see what sine a half is, and it's 30 degrees. So there's my reference angle, 30 degrees. Is this answer positive or negative? It's positive. So I'm looking for quadrants that sine is positive. Sine is positive in this quadrant and this quadrant. So I take my reference angle, 30 degrees from here and 30 degrees up from here. Okay. Measure now from the positive x-axis, so from here to here is obviously 30 degrees, and from here all the way around to here is 150 degrees. So my answers are 30 degrees or 150 degrees. And that's it, guys. Thank you.